In a single sentence, IRSA is about getting access into AWS as federated IAM principles. So if we break that down into more manageable pieces, step number 1 would be to establish trust between AWS and Kubernetes, and step 2 would be configuring Kubernetes, where anytime a service account that is mapped to an IAM role is used on a pod, that pod is injected with proper environment variables. And the last step, step 3, being mapping the actual service account into IAM roles. So the provider is now registered, so the pod identity webhook is running. It would get called every time there is a pod creation request. Then it will create a service account projected volume token and then attach those two environment variables into the pod. So at this point we have completed step 2, where we configured Kubernetes to inject environment variables into pods so that those pods will be able to use the assume role with web identity provider in the credentials loading chain. Right, so that takes care of step number 2. Now let's go into step number 3, where we would actually create a service account, create an IAM role, and map these together so that a service account would be able to assume a role and perform the actions granted by the permission policy in that role. Like in the first step, where we had to kind of exchange information from both sides before both steps had to be completed, we are going to need information from both AWS side and Kubernetes side for roles and the service accounts to be created. So let's just go and create a service account. And that's this part done. Let's go and create an IAM role in AWS. I'm going to use an existing role that I used in the last demo as well. This basically allows reading an object from a specific S3 bucket. I can do the same test that I did in the EKS pod identity scenario after this mapping is done. The only thing I need to change in this case is the trust relationship. Now in the last video in pod identities, I allowed pods.eks.amazonaws.com a service principal to perform assume role and tag session, basically to assume this role and generate temporary credentials for the pod to use. In this case, I'm going to have to edit this trust policy so that a federated identity principal is able to assume this role. So to do that, I'm going to edit the trust policy and add a new statement. For this, I'm going to copy the ARN of the federated identity provider registration that I did in step 1. Right, so this statement basically says that any principal that comes identified from this federated identity provider can perform STS assume role with web identity action. So that's what I need as a first step. That's almost all things done from the AWS side. Now we need to get this role ARN and put that into the service account so that the pod identity webhook knows what value to inject into the pod when a service account attached pod is created. For this, we can include the ARN value in an annotation in the service account. So annotations in Kubernetes are basically a way to attach metadata into the resources. So in this case, I'm going to use a special annotation that is looked for by the pod identity webhook to look up the role ARN value to be used in AWS role ARN environment variable. So I'm going to copy this ARN and I'm going to edit the service account that I created so that I can add an annotation into it. So the special annotation that the pod identity webhook looks for in this case is called eks.amazonaws.com/role ARN. But if you think this EKS part is not suitable for some reason, then you can change this prefix part in the pod identity webhook configuration. That is basically out of scope for this video because this is already a lot longer than I wanted it to be. So I'm going to skip those details. Maybe I'll cover them later in a separate video. But for now, I have annotated the service account. So that's basically this part of the architecture done. At this point, we are almost done. What's remaining is for us to create a pod with this service account attached and see if we can actually access that object in that specific S3 bucket. So I'm going to create a test pod with the AWS CLI in it and just keep it running for 1 hour so that I can do my own troubleshooting. Before creating the pod, I'm going to do a couple of changes to this definition. The first change is to make sure the pod runs for 1 hour so that I can exec into the pod and do my testing. And the next change is to attach the service account that I created and annotated with the role ARN to this pod so that the token that would be injected into this pod would be able to read that object from that external S3 bucket. I'm going to create this pod by applying the file. And after some time I can see that the pod is running. So the first step here for me is to check that the correct environment variables are injected into the pod. So in the architecture diagram, we are at this stage where the EKS pod identity webhook has stepped in and injected environment variables based on the service account that we attached to the pod. So if I describe the pod, I should see the 2 environment variables and the service account token attached to the pod. So if I scroll up, environment variables are here and the correct role ARN has been put into this environment variable, and AWS Web Identity Token file points to a file inside the pod, and that file is a projected service account token volume. So right now all the information have been added to the pod. I'm going to exec into the pod and try to download the file that is specified in the role that is attached to this service account. Alright, so we can see that I can access that specific file and the file content is right. So at this point we have completed a basic IRSA deployment, and that only took, I don't know, maybe 2-3 hours of explaining stuff, but that's exactly how complex IRSA can be. Right, so to recap, what happened when I created the pod was the pod identity webhook was engaged. It checked that the pod has a service account attached. So the service account that I created and annotated got picked up there, and it read the AWS role ARN from the service account annotation, and then it injected 2 environment variables. One is the role ARN that I actually included in the annotation, and second environment variable was the path to the service account projected token that it injected into the pod before adding the environment variables. So when I went into the pod and executed that AWS S3 API get object command, with those environment variables present, the AWS SDK determined that it should use assume role with web identity credentials provider, and it called AWS STS with the service account token that was issued by the API server. So if we take a look at that token that is provided to AWS STS, we would see a claim called ISS, which basically stands for issuer, and depending on that line, AWS would be able to map that token into a federated identity provider registration that I did. So AWS will talk to the OIDC discovery spec, basically well-known OpenID configuration endpoint, and get the place where the signing keys are. And then by verifying the token with the signing keys, AWS will be able to verify that this token is issued by an actual federated IDP that AWS already trusts. AWS will let the holder of the token into its boundary as an IAM principal. And since we build the trust relationship between the role and any principal that comes from this federated identity provider, the holder of that token is able to assume into the role and generate temporary credentials. And using those credentials, it was able to download that external file into the pod. So that's basically how IRSA worked under the hood, but it took a lot of time, understanding, and a lot of complexity behind the scenes for that to actually make sense. So while we are here, let's take a look at the service account token that is generated inside the pod. To read the actual token content, I'm going to base64 decode the central part. And we can see that the output is a JSON object with certain entries in its body. So one of the first entries that AWS is interested in this case is this issuer URL. These entries are called claims, and this issuer claim is what AWS is interested at in the first place. So depending on the issuer and the audience value, AWS is able to map this token into a federated identity provider registration. So if you just wanted an IRSA deployment, I think at this point you could be done You could probably go out there and say that you have done an IRSA deployment and you could do it again, maybe by watching my video. So a reminder to like and subscribe if you like this content. Alright, so this is a good place to wrap this video up. Please keep a lookout on the channel for the other videos. If this content was helpful, please like the video. If you haven't subscribed already, please subscribe. That interaction helps the channel a lot. And also you'll be getting notified when other videos come out. That's it for me for now. Thank you so much for watching. I'll see you in the next video.